I know. How are you?
Hey, lad.
Just a heads up, I'll have a hard stop at 9:30 today.
Yeah, I don't think we will go over 9:30.
Yep.
Um, yeah, I don't even know who's going to join in, so let's wait and see.
Yep. Hi, Morgan. Hi, Kevin.
Good morning, Elad.
Morning.
Hey guys, can you hear me?
Yep.
Okay, good. How you doing? Good morning.
Good morning. We'll just wait maybe another minute or two and see who else joins.
Hey, hi Anu. I sent you a note about the recording from last Friday. I don't know
Oh,
if you saw that, but do we have one? Do you know?
did I not send you? Oh, darn it. I don't know what I did. This whole
Uh,
recording thing is not
it's
quite
so
having.
annoying that people can't just find it. It's so great that they're recorded and so annoying that you can't just go find
Yeah.
it on your own and they're not organized in any manner. But I'm curious to hear feedback
Oh,
on the OCP and what people said in the meeting.
yeah. Did you actually ask me for it?
I believe I sent you an email on
Okay, I don't remember.
Monday,
Okay,
maybe, but
because I sent it to someone else who asked me for it, so I'm just going to forward.
great.
Rita from Synopsys asked me for it, so I'm just forwarding that to you. So you should see it now, Kevin.
Awesome.
So looks like this Friday also there'll be some more discussions about it, and you
Well, I
know
saw a note from Cliff. Is he taking over your meeting on Friday?
some part of it, yes.
Some part of it. Okay.
Yeah,
I,
because
I,
he
I
knows the rules about how OCP can participate. And really, I think we participate as the collaborative supportive arm, but it needs other folks. So I think we act as sort of we manage the money type thing, but not really. Yeah, I don't know. Some such thing. If you don't ask me, that's why Cliff does what Cliff does, and
sure.
I don't do
Okay.
it. Yeah.
Got it. Thanks.
Okay, and let me know if you don't get that mail.
I
So
just got an email from you, so I
perfect.
will check it out. Thank you so much.
Thanks. Um, so Elad, one question I had is what did people think of the NoFo, especially the die-to-die interface portion? So if you after you discuss the other things, I'd like to just see what people's thoughts are.
Sure. I mean, unless Kevin or Morgan or others had other topics, I'm happy to jump there. Other folks feel free to chime in.
I do not today.
Sounds good. Yeah, I mean, I think we had touched on it some already. I guess have others had a chance to read over the NoFo or?
I have not. Other people from here are.
Okay, I've read it. Morgan, have you read the NoFo?
No, I don't know what a NoFo is.
Lucky you, Morgan. Um, I can put it on the chat window here, unless someone has it handy.
It's a notice of funding opportunity.
There you go.
Okay.
And I don't know if Majid's seen it either. Then maybe this is not the right place to discuss that, Ila, if it's just you and me,
It's
because you and
fine.
I have talked about it.
No, it's fine. Yeah, I mean, I think, obviously from the vision perspective, ignoring for a moment what the packaging technology that enables it is, um, it is a fairly good match to sort of the Flex I version of things that we've been talking about from a
Yeah.
data interface perspective, I mean,
Yeah.
specifically.
I think the Flex side didn't really look at the abundance of wires though.
No, I think we did. It's more, how should I say this? I think in some of the early discussions we might have, sort of thought of it as a very, very narrow thing, but
Extension. Yeah.
yeah, no, well, narrow I meant in the sense of the number of wire count. But I think the same basic principle actually, sort of works out very, very well for the abundance of wires in the sense of you do want a single data rate, type of design. You want,
Yeah.
obviously very relaxed sort of electrical requirements and so on and so forth. Granted, some of the like exact, let's say, drive strengths and things like that, you probably would tune differently for, let's say a 3D or other, sort of implied extremely dense type of interconnect. I
Mm.
think that, all the basic pieces they otherwise are pretty much in line.
Yeah, I think for when we talked about the flexi, it was more of um, we needed for low data rate purposes, but we also have a low wire count. And so if we had to use standard packaging for that, would be totally fine. This one, like you said, extends it to low data rate, large number of wires. So you need a very fine pitch, sub 10 micron or whatever he's talking
Right.
about.
And I think, I mean, even in the slides from the summit, I think we did sort of expand the use case for the FlexEye to handle that scenario as well.
We did it. We talked about potentially whether they should be two different focus areas. The really, really wide one, almost a bow 3D or something. I don't know. Anyway,
Yeah.
cautious thinking about, because it's kind of like it's low speed, narrow wire bond, um, and super wide, still a simple phi, but is that really the same thing? I don't know.
Yeah, you're right. So Kevin, we did talk about doing the .3D version post summit. And I
Yeah,
know Cash said he would put his thoughts together as a
yeah,
starting point. But for sure that would be uh, based on a hybrid bond type, which today I think is probably a 10 micron type pitch. But obviously we're looking a little if it's more ambitious to something even finer grained. Um,
right. So that was really are those two this? Do we want to call them the same thing? Is it the same spec extension? And until
yeah,
he
correct.
puts pen to paper, I'm not sure
I
how
think the
that's going to work.
one
Yeah, I
there's
have actually looked at
uh
some of this, and I think the main thing would mostly be sort of ESD levels and drive
yeah,
strength.
ESD, exactly.
But besides those two, I actually think it lines up pretty well.
Yeah.
Okay. Well,
Hey,
cautious here.
sorry, I was late. So yeah, I actually did prepare a few slides on
Oh,
this.
there you
Is it a
go.
good?
We
Is it a
have the
good?
man here. Yes.
Yes. Hi.
Okay. Um, I just have to make sure I don't give all my secrets away and choose the
Oh,
wrong.
come on. This is just friends here.
I know, I know. Frenemies, let's put it that way, right? Uh, okay, so I just made a couple of whether we however we call it, right? I mean, a lot. I think you looked at this as well. Yeah, I just put a few slides together. I'll go through all of them and then I'll open it up and then we can go through in detail and get people's feedback, right? One was our initial approach was just a standard phi, right? And obviously, if you want to use it for, I put UCI 3D in here, but it's really doesn't, I know we can't put that in an actual spec. But that sort of simplify with half clock delay is an option, right? And then that's certainly something to consider. And I'm not talking about the naming convention or however we want to slice and dice it, but it's just in general, right? So the idea being that, okay, do we want to also consider having not just a standard side channel phi, but also a pathway to using a simpler phi, right? And I've even had customers asking me, on the receive side of all places, or on the sense, on one side they wouldn't want to be able to flop it, but not on the other, right? Where they can flop it I guess it's on the receive side, right? They want to flop it potentially. And these are all items for discussion. I'm not proposing anything. I'm just put that note in here. I think from a spec standpoint, it's much cleaner to have it flopped on both sides. Elad, you're an expert in this. Is this even something to consider? Letting customers do what they want, or in reality, they'll do whatever the heck they want anyway, right?
Yeah,
So
no,
this is the question.
people do whatever they want anyways. I mean, I think from a perspective of if you want to build a standard around it, if you don't actually flop it, it sort of becomes more challenging to write what whatever the spec would really be. Because
Right,
you're sort
right.
of somewhere in the middle of the signal chain and
Yeah,
somebody somewhere still has to flop it and you don't necessarily know kind of what they're doing.
yeah,
It's
yeah.
not that it's not
Okay.
possible, it's just, it'll be more let's say frustrating from a spec perspective.
Okay. So it's not even worth pursuing. I just wanted your input, right? Because I'm
Yeah,
sure
yeah,
you've looked into this and customers have asked for it, and you can always do custom versions for people if they have money, right? Whatever they want to
of
do.
course.
So,
Yep. No, I mean the half
okay.
clock delay I think is sort of what most people are expecting.
Right, right. So I think that's the logical way. That's the only logical way to do it. So,
Hi guys. Kash, before you move on, hi, that's Majid. Just to understand, is this kind of the discussion about how to respond to the abundance
no,
layer, or just a
no,
different?
not in general. I mean, we've been working on a more flexible PHY where people want to be able to use, different numbers of pins and asymmetric links, and also go for maybe lower power, lower latency. Therefore, you don't have a more complex PHY. So this is a PHY. This is Bow Flexi, which is no
Oh,
serializations. SDR. We can support asymmetric so that you have more RX than TX, depending on which side of the link you're on, if that's what you want, right? So that's and now we're starting. Okay, how do we want to define it, right? So and there's two thoughts. Well, there's two in reality there are two applications. The question, which we will come back to later on, I think, is this Bowflexi 3D and Bowflexi regular, or is it just is the 3D a completely different version to save, or whatever, right? So I think that's a separate discussion, right? So
by the way, the term flexi is taken. Huh?
is it
It's
by
a IEEE standard for 4G, etc. In Ethernet, they added a flexi shim layer. So you could look it
Just
up.
double check. It's spelled as flex and then E or flex and
I?
then I.
No, flex
Yeah.
E.
Yeah, no,
Yeah,
we're
yeah, yeah. We're talking
flex
about FlexI. Yeah, I'm familiar with FlexC for Ethernet.
Okay.
We're talking about flexible. It's called flexible interconnect, right? Which is FlexI, but
Okay.
it's pronounced Flexi. I pronounce it Flexi. Maybe it has to be FlexI.
Right. Okay. Okay. Got it. Okay.
Yeah.
No.
So I
But
think
so
I
okay.
think
So that's the request going toward this customer requirement of really more flexible. Okay. Fine.
yeah. So you can do for IoT kind of applications if somebody wants only to do four lane links, for example, right? And they
Okay.
want a very small area or 8 lane or whatever, right? So there's customers who want a simpler PHY. And I think that there is this 3D thing. I have interest, and we know of people having interest in a simple PHY with a half clock delay for 2D or 2.5D as well, right? So I'm not a fan of just saying it's for 3D, but obviously it's the same. Essentially, it's the same PHY. But again, as Elad said, you obviously have different other issues if you want to do 3D, right? Which is it's designed for ultra short reach, right? And ultra low ESD, right? So there's justifications for calling it something completely different, or I don't want to get into that argument, right?
Yeah,
So
we,
it's just
we can do
yeah,
sort of the same trick we did in
yeah,
the original boat spec of, there's sort of like requirements for differing data rates slash, sort of
yeah.
nodes and just
Exactly,
sort of the same thing, right? So
exactly, exactly. Um, the other thing was on the channel options. Currently, we've got standard ESD, right? For Bow, which is 50 volts, right? And the reach is I'm sorry, my these days like showing up as short reach and medium reach. So the standard is 10 millimeters and long reach is 25, right? We have lots of people interested in equivalent of a very short reach and for low power and low cost reasons. So we definitely want to see an option for that. And the standard is obviously 10 and 25, right? So the thought would be to keep those. But for this one, you may want to consider doing a lower voltage because if somebody's trying to do very low power and the two die are very close to each other, right? Whether it's, whatever that mode is. So I think that's something for discussion and comments.
So
Bilal, do you see that?
sorry, there is no lowering of the pitch consideration.
I'm going to come to that.
Oh, okay.
Yeah, just on the very short reach, I'd probably go at about 2 millimeters.
Okay.
I think 1 millimeter is quite a short distance, right? But I think 2 millimeters is reasonable.
Yeah, there's some other stuff we're looking at where, I think from a spec standpoint, you can say one, right, or even less than one. And to your point, in reality, if you're putting it on a regular substrate, it's hard to do anything less than two, right? So, um, depending on the substrate, obviously.
So Kash,
Um,
this is all sort of conceptual for our own thinking, but don't necessarily fall into the spec in some way, or are you proposing?
I'm just trying to throw, as we try and put stuff together, is do other people see this? And then before we drive into the spec specifically and say what do we want to make it? The current approach is just the spec is just the standard pitch and these two, right? Okay, I'm sorry, do we want to put in the spec that we support a very short reach?
Well,
So somebody, for example, for low power could decide to do a much lower power short reach PHY if they wanted to, right?
yeah, I guess maybe just to
And do
clarify.
we want to standardize that or just not worry about it?
Well, I think it sort of ties back to this to the earlier discussion in the sense of the spec itself doesn't actually say anything about either pitch or reach. Right. Both of those are sort of left up to the sort of implementer to decide. Um, there
No,
was
yeah, yeah,
choices
I get it.
made based on, sort of originally when it was done as a sideband, there was various choices made there. But so I think the way to sort of handle what you're describing here sort of all just comes back to ESD and drive strength requirements. I think
Yeah,
those are the two big
yeah.
knobs. And, if we just define modes, quote unquote, for those, I think that'll hit everything you want.
Okay, okay. Yeah, so as you say, there's nothing to stop somebody from just designing it for 2 millimeter reach or 3 millimeter reach because that's what they need, right? The question is, do you want to let people know? Because I think if you say it can do everything, I just think that we lose something by not saying that we have this. It's like SerDes, right? People ended up saying we have a very short reach and then ultra short reach and
Yeah, no. So
long reach and
to
extra long reach
yeah,
versus
yeah.
just saying you can do anything. So I was just on that
No, I
mode of
understand. Kind of two thoughts there. One is, yeah, I mean, I don't. There's no reason to not provide people the information slash guidance, right? That I certainly
right.
agree with. Um,
Okay.
the other is, and I think you've probably seen this before, right? That there is actually kind of a dotted IFI categorization thing that we've put together and presented in a few places. It slices things sort of slightly differently than just the reach. Reach is one of the aspects, but there's kind of the pitch and let's say power density slash cost requirements are also
Mm-hmm.
thrown into there. I unfortunately have a hard stop in 10 minutes, but I'm happy
Okay.
to go over that here in this forum next time, just for another sort of stab at it.
Yeah. So this was an item for discussion. Is okay. So we should
No,
discuss
I do
this, and
think
yeah.
the categorization I think is helpful for the same reasons it
Right.
was in 30. So yeah,
Right.
no pushback there whatsoever.
Okay.
Yeah, on our
Um,
side, while we're at it, we see on the other end of the spectrum much longer reach as well.
exactly. No, I've seen that too. Right. So I didn't put that in here, but almost like a chip to chip. Almost people want almost like a chip to chip mode. And it's even higher ESD than 50 volts, and for some customers, we haven't done it because they haven't been willing to pay for it, but it's definitely some interest. So yeah, I mean, I think it would make sense to say that there's potentially an option for. I don't know whether the phi has to change for that. Do you see a need for higher ESD, or you can just keep the same ESD at 50 volts?
Yeah, it depends what exactly you're doing, but I think if I interpolated from both of the comments, typically the ESD requirement does get larger.
Right. Right. Okay. So I think it would be good to, if we can codify it a little bit and just say, hey, there's an option. You're not required. You don't have to do it, right? And you can just say, I've got flexi with 10 millimeter reach or 3 millimeter, well, whatever, however they want to brand it. But there should be something that says, or we can call it extra long or whatever. What Majid, what length are people interested in that you're seeing?
You said it is chip to chip, really.
Yeah, yeah, okay.
So
Same kind of application. Yeah.
yeah, 100 to even more.
Yeah. Yeah.
Once you're chip to chip, obviously the ESD requirements, go back to what everyone knows and loves, so to speak.
Yeah. So originally in OIF, actually, we presented our technology for that kind of thing. So yeah, it's in the
Okay.
OIF spec.
Okay. Um, and I think this is where some of the thoughts are, um, do we put an advanced packaging? I mean, obviously, I think we need to, but advanced packaging options. And as we know, there's talk of 10 micron and 1 micron pitch and so on. So obviously, we need to add at least optional lower ESD, and what is that number, right? Is it 10 volts or with an option for 0? Because that's more just following, the other spec. If people have any thoughts on that, do we specify a number or just say that you can make the ESD per the customer request and you just have to state it, right? If you're a phi vendor.
Have you guys kind of looked at glass substrate? That's a kind of technology trend that some of the people I worked in the past, they're kind of driving it as investors and all that.
Well, yeah, I think a lot of people are talking about glass substrates. I don't know much about them.
Yeah.
Elad, that's your.
Yeah, no, trying to figure out what I can say. I think most of those efforts that I'm aware of are sort of more looking at it in the, let's say, equivalent of quote unquote standard package kind of context. Um, there are some things that the people are talking about where, it sort of pushes more into the advanced side of things. And yeah, I mean, I think that's all interesting, sort of generally speaking, from let's say BOW spec perspective. I think it doesn't necessarily change anything in the sense of, all the specs were derived from, sort of essentially signal integrity requirements and considerations. So folks are free to swap those things out, mostly speaking. Um, in the let's say in this particular context we're talking about here of like ESD requirements and things like that. Um, yeah, I mean it's another option. I'm not at the moment aware of directly how it influences the sort of the ESD per se. But maybe to circle back, Kosh, to your earlier question or suggestion, yeah, I mean, I think there's a couple ways, right? One would be that, we have, let's say, different groups of categories and sort of say, hey, if you're in this type of scenario, you should have this level of VSD. If you're that type of scenario, you have that level of VSD. Or as
Mhm.
you said, we can just say, well, vendor needs to specify because, depending on what you're doing, it could have very different requirements. And I kind of like that in the sense of that's probably the practical reality of what most people end up doing. The only downside, obviously, is we're not necessarily giving any guidance there, but we could always sort of have that as a, hey, generally the numbers look like this.
Right. I think it's good to have also let people compare PHYs at some point, right? Say, hey, you should. I don't know. I mean, I think this is where it gets to. It is going to be a wild west to 1 micron pitch. Should it ever happen in my lifetime? And so things are going to be changing, right? But quickly, I know you have to leave. I've just been asked, why can't somebody just have 8 bits as part of this, where they just say they want to send it unclocked? It's almost like regular, particularly as you get to really tight pitch, they just want to use this as a control mechanism, some pins, right? Some number of pins, for blocks of 4, blocks of 8, or whatever. So there's nothing to stop anybody saying it, but do we want to kind of offer it as that? You can use this PHY without blocking and make that an option?
Yeah, I mean, how should I say this? I would sort of refer that as like an IO design and not a PHY, if that makes sense. In the, in other
I
words,
understand. But the people always say, why can't I just do this? Obviously they can, right? So it's a question of, okay, do
yeah,
you
no.
codify it
So
in some way?
yeah, no, and again, not opposed. I mean, I think basically the implication would just be that, perhaps when we, well, perhaps when we write this version of the spec and say, look, like here's sort of just the raw IO part of it, and here's the, sort of the PHY part of it. If you happen
Right.
to want to use the raw IO, have at it, right?
That's a good idea. I just want to, because people for some reason think that you can't do it, so you have to. It's obvious you could do it, right? So it just would be, simpler for people if you could just say, okay, for die to die, you could just use this IO structure, and you can configure it as a PHY that does this, or just an IO essentially, right?
Mhm.
So I think that's a good way of doing it. I try to put in here all the things that we should discuss before we go and try and route things. Uh, the other thing that I've been asked is on security. Is there a way to add some sort of a simple consistency security check? So without going deep into the
Yeah,
security
it's a
bubble where
it's
people
a
then have agendas.
reasonable question. I'm laughing a little bit because if somebody's actually gotten your 3D integrated wafer or whatever and flipped them on top of each other, I think your security does
Good luck to them, right? Good luck to them with.
there's some
I
other
get
problems
it.
you probably need to deal with, but yes, no,
Yeah,
it's a valid
yeah.
question.
No, it's just like exactly, but the idea is I don't need. The question was, but I mean it's relevant because
Yeah,
one
no,
approach is you need some root of trust and all this other crap, which adds so much overhead.
Yeah, I was going to say, does it remain simple anymore than when you add these, or can we just have a reset or a
I mean,
some?
the discussion in the past was the security really should be a sort of, chiplet level decision that, sort of
Right.
handled in a more cohesive way. And it's not really the data interfaces, sort of job, so to speak, to handle that. That was the discussion in the past, right? That's not to say that's still the correct answer. That was
Yeah.
that was the conclusion in the past.
So
Right. Okay.
so the idea, so at least the ask was just if there was a way to just say, hey, I know that on the other side I've got something that looks like what I had before. I don't know, right? So I'm not a security expert, but
There is some activity in the other standard with these
yeah, but
sort of
it's run by yeah,
sideband
yeah,
long
yeah,
reach type of
yeah,
simple but related to security.
right. So yeah. The problem with the other standard is yeah, I won't go there. Okay, it has some great things and a lot of bad things from what I hear. So it's yeah. So I will stop sharing. So
Fair
I
enough.
just put
On that note, I'll
together.
apologize and have to step out, but please keep going.
I caused you to leave. I'm sure
There
you're
you
very
go.
upset. I'm sure you're very upset at that statement.
I'm mortally wounded, yes.
Okay. So that's
Thanks,
what I
man.
had. I just put the foundation kind of areas for us to talk about as we write this, and then we depending on what everyone's feedback is we can split this into different areas or segments or subsegments, or just make it too different. If for business reasons we need to say it's a radically different approach to go this 3D super tight pitch versus more flexible. So the reality is particularly for the short reach version of Flexi, where the die are a few millimeters apart, it's essentially the same die architecturally. So I'll leave it at that.
Yeah, the sideband version, right?
No.
Oh, this is more than
This is more the half clock version.
okay.
But yeah, so we'll talk about the idea is to talk about it, not just generate a spec, right? So I think we should get feedback from other people. I'll send you a copy of this document. Where do we want to keep the files, and then
there's the Google folder there.
okay, I'll try and upload it.
I
find
think
the
you've
right one.
got permissions to write there, and so maybe
Yeah.
I don't know if there's a Flexi folder. Maybe we should start there and then start putting.
Okay.
It hasn't changed for a while, the same place where.
Yeah, I don't think it has. So let me see if I can find the link right now. Yeah, I'll just send the link on the chat.
Is there any activity here with this CHIP Act at all? I know that we talked about it, but
oh, go ahead, Kash.
I was just going to say, I think Cliff sent out a note.
Yeah.
I think 8 o'clock on Friday.
Yeah.
Session is going to focus on that. And then I think that our group will also address that as we learn more about who might be interested in talking about it from the PHI standpoint.
Yeah, so Majid, the 8 a.m. call on Friday, if you could join that.
Sure.
It's going to be recorded, but definitely share the recording post it in a place where everyone can see. But if you have a chance to join.
I attend that.
Okay.
Yeah, thanks.
So there's a Flexi folder, Kosh, on.
Yeah.
I see it.
Okay.
I'm also going to have to drop, so I will look for your slides there. But good stuff. Thanks, Kosh.
Yeah, no, thanks, Kash, for putting this together, starting conversation. And then I think everybody's got to go back, review, and then let's discuss next time our thoughts. And then, going towards the NOFO, is this something also that could be a prototype for this, which is a flexible interface? Of course, he's looking for sub 10 micron pitch only, I think, in the NOFO. But is there some way to get some funding for this activity? Would be my take on it. But I don't think it can be directly to OCP. It's got to go through. Yeah, I don't know. Cliff has those rules. I don't understand it. But
yeah, I don't understand the rules myself. I don't. But basically, I think that we should try and find a way to participate and propose a PHI for that standard. Not that there's a standard at the moment; it's just a wish list. And think through what would it take to support a 1 micron to 10 micron pitch, right? And eventually, this is definitely going to happen, right? I mean, I know people working on it, right? So, so we just leave it at that. I think. Majid, is are you guys interested? Because I think the other part of this is trying to find how do we even connect with other companies that might be interested in leading a proposal, or how do we, because the whole idea here is that a number of companies are going to team up, right? So I think that should be an area of, I guess, discussion on Friday, right? How do we enable companies to find what they're offering or what they can offer, and so on and so forth, right? So I think that would be good.
Right.
So Majid, on the substrate side, do you have people that can do the 1 micron, 10 micron substrates? asking for a friend.
No, yeah, I think this is all new. In our focus is something else. So yeah, we have to see how it fits to our, bread and butter and strategy.
Okay.
But I think we have this advanced R&D that looks at these moonshots and stuff. So uh, if we could have some business driver or some other technology driver, then yeah, we would be interested.
Okay.
But I finally listened to some of these Bapi's video, other things. So I would be interested to know, those who have had close exchange with him, how these goals and directions are set.
Yeah, I don't think
Yeah,
you can
I'd like
say.
to
I
know
think,
too, Majid.
yeah, we'd like to know. If you find out, let us know.
Right. No, because there must be evidence that such direction is set. And it could be academic, whatever. What I understood,
Yeah.
there was some academic reasons for it, and certainly a lot driven from packaging direction side, and that makes sense because it's not all about interconnect packages front and center. So yeah, but it would be interesting. I guess if we could have some context, because otherwise people, even within the company, they look at it, okay, it's interesting, but it stops there, right?
Yeah, no, Majid, I had the same reaction here. It's kind of like, oh, this is fascinating. Some university will do some research towards it. That's great. But how does it work for a company that's trying to stay profitable
Right, exactly.
and get into the business? Yeah, it's a little, yeah, different.
Well, they're in a catch-22. They want something that is, let's say, bleeding edge, right? But they also want a demonstrator of running AI or whatever, right? An applications or set of applications on using many chiplets. And $75 million spread across 4 or 5 companies over a 5-year period is not a lot of money. That's the other challenge here, right? So
Yeah, it's good for academic work, I think, or really seed startup. But no, I agree with you. This is, but I'm a bit puzzled. It's almost like solution is or direction is given. The problem statement is less clear to me. But yeah, I'm sure don't understand it more than anything else.
yeah, well, I think in general I think the statement was I think driven by is it Professor Iyer, right? Who's the I don't know his title. He's the technical wizard. Um, Essentially, I think his argument for a while has been that um, the die-to-die IO has always been a limitation, right? And now with advanced packaging, limitation is going to go away. So that's why they've coined this term abundance of wires, right? It's like in the old days when you used to design to maximize your logic, right? Gate count. Um, Now nobody cares. Or in the old days when you were writing code, the amount of memory something took was incredibly complicated and important. And then in our business, the number of I/O has always it's become an issue, right? Um, and what they're suggesting is that that's going away, and I think they're right. Um, I'm not sure I understand exactly the prescription they've come up with, but that's a different
Yeah, but
argument. But I think yeah.
some of the barriers to it, for me at least, understanding the market is, advanced package is super expensive and very limited access of people. so somebody's seeing on the wall that the cost curve and technology curve is there is enough momentum that this is going to change everything in the 5 year, because this is a very short period of time given where
Yeah, I think that's hopelessly optimistic.
advanced package today is, NVIDIA has access, and Intel and a few others.
Yeah, it's really for the big players, right? Because they can afford it. Yeah.
Yeah.
Well, yeah. So I think that's the challenge, right? It's as I try to explain to people, the vast majority of semiconductors by volume are less than $10 or $20, right? So you can't have a $10 or $20 package, right? It doesn't work, right?
Yeah.
So it's a challenge outside of the AI and data center space.
Right.
So maybe on Friday we hear something. Somebody has more thoughts.
Yeah. So at least that's all we know. Okay, Morgan, did you have anything on the memory or?
No, I haven't had a chance to get back to that.
Okay. No. All right.
Yeah,
All
no
right.
worry. We'll chat again next week. Thanks, everyone. Thanks, Cash.
Okay.
Thank you. Good.
Bye.